This is Unit 5, Lesson 1, Congruent Figures. Congruent figures have the same shape and the same size. When we talk about shape, we're generally dealing with their angles. In regards to size, we're generally talking about side lengths. The congruent symbol is an equal sign with the tilde on top. What this particular symbol means is similar, meaning that the angles all have the same relationship and that the side lengths are exactly equal. When figures are congruent, you can move one so that it fits exactly onto the other. There are three moves. There's a slide, a flip, and a turn. If you notice, the rectangle could be slid directly onto the other rectangle. It is exactly the same in both shape and size. This four-sided figure can be slid or flipped onto the other, and the triangle can be turned or rotated so that it slides onto the other. An example of shapes that are not similar, I have a star, so these are similar, they fit exactly on each other. If I were to expand, they were congruent. These are similar in that they have the same angle measurements if you were to put the tips on top of each other, but they do not have the exact same
Good morning,
size.
Seniors. A reminder that this morning there is a STRIDE meeting. Again, for all seniors involved in STRIDE, there is a meeting this morning. Thank you.
Sorry about that. Bottom line, when two polygons are congruent, you need to make sure that you have all corresponding sides congruent and all corresponding angles are congruent. By corresponding, what do we mean? We mean the sides that lay on top of each other. So AC and MH, if you slit them on top, are corresponding. Those have to be congruent. That CB and TH have to be congruent, and I'm going to mark it with a double. That AB and MT have to be congruent. Same thing with angles. Corresponding angles need to be congruent. I'll mark them single, mark them double, mark it triple. The purpose of the alternate markings is so that you can understand which ones are the same. You don't necessarily want them all to be the same. So, congruent statement. What is a congruent statement? A congruent statement is a statement where you're telling me that two things are congruent, but the order of these letters is going to matter. So if you want triangle ACB, then you need to make sure that the second part of the congruent statement corresponds. So since A went with M, since C went with H, and since B went with T, and the triangle symbol in front. There are other orders that you could make these as long as the second part of the statement corresponds to the same order as the first. Write a congruent statement for all the corresponding parts. In regards to corresponding parts, we have three congruent sets of angles and three congruent sets of sides. So I have AC segment congruent to segment MH. Those two could slide on top of each other. CB is congruent to HT. And AB is congruent to MT, both segment lengths. In regards to angles, angle A is congruent to angle M. Angle C is congruent to angle H. Angle B is congruent to angle T. The purpose of the next slide is to just briefly discuss the importance of a congruent statement, so give these some thought. AC, it looks like it's congruent to MH, and if we use the same diagram as the previous slide, it is. So has the correspondence changed from the previous slide? No, it hasn't. But go ahead and look down here. AC is congruent to, well, AC is over here. It looks to me, visually, like it might be congruent to TH. So the purpose of the congruent statement, has it changed from the previous slide on the other, like up above? The purpose of a congruent statement is so that you're not guessing as to what looks congruent to the other. If you were given a statement that said triangle ACB is congruent to triangle, what did we have on the other page, MTH, then you're not necessarily guessing what looks like what. You know for sure what things are congruent, even if a diagram is not drawn to scale. Are the triangles congruent? How do you know? Explain and write a congruent statement. In order at this point in the unit to deal with congruence, we need all three pairs of angles and all three sides congruent. So far, I can recognize that the given that angle B is congruent to angle P because it was marked, it was given to us. I know that DG, segment DG is congruent to segment MG because it was given to us. I can recognize that angle BGD is congruent to angle PGM, making sure to use all three letters here so that you know what direction the angle is going, because they're vertical angles. But that's all I can assume at this point. So given the current information, no, I don't know that the triangles are congruent. But this might help. This says that if two angles of one triangle are congruent to two angles of another triangle, then the third are congruent. Think about it for a moment. Let's just pretend that this angle here is 30, and if they're congruent, that one's 30. Let's pretend the one up here is 70 and 70. We know that triangles add to 180 degrees, so that 70 and 70 is 100, that one would have to be 80. So the purpose of this theorem is allowing you to know that if two angles are congruent, then this third angle must also be congruent, even if we don't know all the angle measurements. So I know that angle BDG is congruent to angle PMG. And if you notice when I'm making my angle relationships, I'm attempting to put the letters all in the same order. So right now I have three angles and I have one pair of sides. So again, we cannot show that these triangles are congruent. If we had to, we would need more information. To show these were congruent, we'd have to know that these far sides were congruent, and we'd have to know that these longer sides were congruent. But currently, those angles are not congruent. All right, these last three are all you. My expectation is that you've watched the video, you've taken notes, you attempt these three, and we'll go over them in class. Thank you.